All right, inclined planes. Um, so this has been the situation we've been kind of talking about so far, is if something's on like a level surface and FG is equal to FN. We kind of had one point there where we were pulling something on an angle where FG wasn't equal to FN, but yeah. Now this is going to actually be kind of similar to those type of questions where we had like a rope pulling off to the side, because now what we're going to do is we're going to put that box on an inclined plane. Now this inclined plane is going to be off on some angle, right? And I need to know that my normal force is always perpendicular to that surface. So it's always straight up and down that way, right? So something to notice though is that now Fn and Fg are not in the same line, right? So what we got to do is we need to make them in the same line. So what I'm going to actually do is split Fg up into its components. And so you can kind of see that I've made like a that should be a right angle triangle down there. Um, so yeah, I've got the y component and the x component. But you might be saying, Mr. Brown, that's not the y and the x. X goes left and y goes up and down. That's on an angle. But all we got to do to make things simple, I'm gonna just say now this is up and that's down, and I'm gonna say this is down and that's up. So I just kind of like tilted my what I'm calling positive and what I'm calling negative. So now the x direction is going to be totally just in the same plane as my slope here. We're allowed to do that. You can do that. You can make this whatever you want, right? We just want to make it all kind of like in the same line. And that's probably going to be the easiest way to do it. The other thing to notice here is that this angle right there in our triangle is actually going to be the same as this angle right here. All right, so hopefully you can kind of see where we're going to be going with this. That we're going to have to add up all of our forces in the up and down direction now, this way, and then add them all up in our other direction this way, and then see which one's actually the net force is bigger in one of those directions, and then figure out the acceleration or whatever it is it's asking for. Okay, so this part here is just talking about how you could find f of x, and that's just using the same trigonometry that we've been using, right? So this is like FG is the hypotenuse of our triangle, so it's just going to be whatever FG is times FX would be sine because it's the opposite side, so sine theta, and FY would be cosine because it's on the adjacent side. If you need to, go back to your trig identities to figure out what I'm talking about there. And then we need to make sure that you recognize that now Fn is equal to Fy. And Fx is going to be, well, maybe not equal. If it was going at a constant velocity, Fx would be the same as the force pulling this box this way, right? Because they'd be equal in length. But it might not be. Maybe Fx would be bigger and the box would be sliding down the ramp. If Fx was smaller than the force applied up the ramp, then it would be sliding up the ramp, or it would be increasing in speed up the ramp. Okay, moving on. So here is a type of question that you're going to see. I'm going to let you guys look through this one because we're going to cover one really similar to this in the practice problems. So that's going to be it for that video.